let me talk about the modifying aerofoils. Then I will jump to the next topic what we have, that is assembling aircraft parts. Okay. So modifying airfoils and assembling aircraft parts. So here we have two topics. Okay. Modifying airfoils in this is whatever I have told in last classes about the airfoils and all. Okay. With respect to your NACA foils or other cross sections, whatever we have. Okay. So for that, how you will modify. Okay. Just 5 minutes topic. Then after that, whatever you will do assembly. Okay, in real life. So similarly, by using Open VSP, how can each and every part be assembled in the Open VSP? That is also I will tell. Okay. So first, let me talk about the modifying aerofoils. Modifying aerofoils, you can shift, you can rotate, and you can scale. So how to modify an aerofoil section? So by changing the X by C, Y by C, and pitch, and leading edge location as well as the scale. So by using these all options, okay, what we have in the Open VSP, we can use these options to change or to modify the aerofoils or aerofoil sections. Okay, and leading edge, trailing edge, shape, size, like the sharp or wedged or blended type leading edge if you want, or trailing edge blended type, or sharp type of trailing edge if you want, that also can be done. Okay, so you can alter the leading edge and trailing edge closure of wing type components. Okay, so I will just complete this by showing the Open VSP. I mean, in the Open VSP, I will show all these options modifying aerofoils. Okay, so here suppose you'll add a wing. Okay, here we have the aerofoils, each and every section. Yeah, okay. So here we have aerofoils set 1, 2, 3, 4, 5, and 6. These are root chord and this one is our tip chord. In this aerofoil, you can change the aerofoil type. I mean the cross section you can change, as I told you in the last class. Okay, so suppose you have changed the 4 series aerofoil. Okay, that is thickness to chord ratio 18% and camber 0.009, location of camber. Okay, yeah, 2% I will keep. Yes, 2% location of camber. The overall camber is 2% and the location of camber is 20% from the leading edge. Okay, so this is what our aerofoil. For this aerofoil, you can do a modification by using this tab. This one, we have the option of modify. Modify in the sense the modification. So what modifications you if you want to do, like if you want to shift or rotate or if you want to scale, that option can be done just by using this option delta x by c, delta y by c, and delta theta, and even you can increase the scale. Okay, leading edge I'm shifting. See, whatever I'm changing this, that is for uh, zeroth cross section, which means road side. Similarly, you can jump to tip side, okay, or else you can split your sections in this section. You can split your sections, okay, one, two, like this. You can split and you can do modifications. If you don't want that, then just cut. That's it. Sorry. Let me add once again. I don't want symmetric parts, that's why I have this checkbox. So default aerofoil is NACA 0010, which means maximum thickness to chord ratio is 10%. Okay, this aerofoil if you want to keep, then just keep as it is. And for the same aerofoil, if you want to do any modifications, you can do modifications by using this option. Okay, cap, if you want to change the cap, then just change the cap, flatten to round, rounded to edge. The effect you can able to see here. And this one, offset length also you can increase. And this closure, you can change the closure none into skew lower. And that value can increase. See, completely therefore got changed because I have disturbed this value. I'll just use 0.1 and I'll enter. So near leading edge side, skew lower I am altering. And if you want to trim, you can trim with some value. Okay. See, I have selected the tip side file, not root side. Okay, that's why the overall effect has been applied to tip side. If I jump to root side, then the same changes can be done here also. You can trim this one like this. Thick aerofoil you can add. Okay, and similarly, trailing edge side you can do whatever I have shown, that is for leading edge. A similar case you can do for trailing edge side. It's rounded. You can change router into sharp edge and other type what we have here, and closure you can change, and similar effect you can do here. See, you can observe the changes what I'm doing here. So like this, you can modify your aerofoil. Okay, and just open one aerofoil, which just aerofoil which I have created. Yes. Okay. So here for being just I have converted into aerofoil. Okay. That is NACA 2412 aerofoil. For this aerofoil, you can able to see the changes. Whatever changes I will do, just observe the changes. Along X I am disturbing. Okay. And along Y you can disturb the aerofoil. Along X direction with respect to the chord and along Y direction, okay, with respect to the chord, and similarly theta in the sense angle. You can rotate your aerofoil with some angle theta. If you want to change the scale 1:1 into 2 or 5 like that, just type your required value. Even you can shift your leading edge. So currently leading edge is here, no? So that leading edge you can shift. See leading edge side, I'm changing the closure with some value. And I'll just trim this. Similarly, trailing edge side. As per your requirement, you can select any one. Okay, like if you want to keep sharp type of trailing edge or blended type trailing edge, or uh, if you want to trim it some value. So just as per your requirement, you just alter these parameters, or you can modify your aerofoils by using these parameters whatever we have here. Okay. See, trailing edge completely got changed, right? Initially it was completely sharp. So this is all about aerofoil modifications or modifying an aerofoils. This is how you can modify your aerofoils. Okay, by using this tab, what we have in the Open VSP modify option. Okay, whichever aerofoil cross section if you are placing, then just create the aerofoil cross section. After creating, for the same aerofoil cross section, you can modify by using this tab. Okay. So now I will jump to next topic, that is the assembling an aircraft parts. As we know, generally the assembly in the sense we can join, or the assembly of an aircraft refers to the joining of parts or sub-assemblies by various means until the entire aircraft is in condition for operation, right? Like this we can in real life industry, this is how they will assemble each and every component after complete fabrication and all. Okay, as you know, like complete fabrication can be done. Okay, and before this we will do all the procedures like designing, okay, analysis part, then real life design and all. Okay, so whatever process we have seen, aircraft design process, those all process or steps what we have after completing that all steps, finally we will fabricate, and after fabrication and all, this is how we will assemble each and every component after detailed design and all fabrication will be doing. Okay, and after fabrication each and every component, this is how we will assemble, like wing, fuselage, stabilizers, engine. Okay, and after assembling we'll fix in such a way that CG has to manage, which means aircraft has to be in a statically stable condition. Okay, this is all about real life assembling. Okay, in our open VSP, as we know, we have the inbuilt components. Okay, like fuselage, wing. Okay, and stacks, pod, engine. Okay, so like this we have different inbuilt components. Let me delete this. Right, these are all inbuilt components: fuselage, wing, stack, blank, and all. Okay, by using these inbuilt components we will design our required aircraft, right? So here, whatever we will add the component like fuselage, wing, okay, ellipsoid. That ellipsoid is not required. Let me select stack. Okay, stack, propeller. Okay, so like this we have inbuilt components. See, I have chosen the option symmetry option. Okay, sorry, here I have off the checkbox. That's why I just got symmetry part of all this component, right? So you can change that. Okay, just use this option. That's it. Wait, let me change this. Okay, yeah. So like this, as I told you, we have different components. Okay, all these components. Okay, by using this all components, we will do assembly as per our requirement. Okay, so initially for the default fuselage, you will change your default fuselage as per your requirement, which means you will create your own fuselage, and similarly you will create your own wing. Okay, the required wing. Okay, and like we have different wings. Okay, as per your requirement, you will create your components. After creating your all the components, then finally you will do assembly. Okay, this kind of aircraft you will create, or you will create this kind of aircraft. Okay, so in our open VSP we have fuselage. Suppose like the default fuselage, I will not change anything. Similarly I will add wing. Okay, and this one I will call as a main wing, and one more wing I'll add, and I'll call this wing as a tail wing. I'll take this wing here, and let me select the stack. Okay, so I'll move this stack along X. Okay, so suppose I have designed, or I have created the required fuselage like this. Okay, and required wing like this. Okay, so now once it's done, like I will call this one is my fixed fuselage. Okay, because I will not do any alterations. Okay, and similarly this is my wing. Okay, and I'll call this one as my main wing. I will not do any alterations. Just here I will show that how we can do the assembly. Okay, in our open VSP, how to do the assembly for all these components. Okay, so here the fuselage, I will fix this fuselage. Now I will select the wing. I will call this wing as a main wing. So I'll move this wing along X. Okay, yes. So let it be here. I'll change the view. Okay, so now I'll do little bit alterations. I'm gonna change the wing parameters of this main wing. Okay, I'll increase the span and the chord. Okay, let it be. And now I'll jump to the second wing, and then I will call this wing as the tail wing. Okay, and I will decrease the wing parameters, that is the span and the chord length. Okay, so I'll just little bit I'll move along X location. Okay, so what I'm doing here, I'm just assembling. Okay, now currently I don't have any dimension, just roughly I'm assembling, because to show you like how we can assemble by using these tabs what we have in the OpenUSP. So by using this tab, you can adjust your model, I mean your components like main wing or tail wing or fuselage. If you know your values, like say along X, if you want to fix 22 unit. Okay, these are like non-dimensionalized value. Okay, so just type 22. So if it is 22 centimeter or 22 feet or 22 meter. Okay, so at the end you can export your non-dimensionalized value into required SI unit values or your required measurements that may be in a centimeter, meter, or feet, like that. Okay, so here now currently I have just typed 22, which is non-dimensionalized value. Okay, so I will call this one is my tail wing. Okay, that is horizontal stabilizer, and we want now the vertical stabilizer, right? So for that case, what I'll do, I'll just copy this same tail wing. I'll copy this and I'll paste. Okay, so here I got the extra wing. Okay, so for this case, what I will do, I will rotate that wing because currently that wing has uh, flatted one above the other. Okay, it's horizontally placed, so I just convert this horizontal into vertical, and I will call that as my radar part or vertical stabilizer part. Just let me change the view. Okay, and I will rotate the extra wing along 90 degree. Yes, done, right. And I don't want symmetric part, so that's why I'll off this. And let me have a view, bottom view. Okay, top view. Okay, so now I'll just come to stack geometry, and I'll move this along Y. Okay, okay, let me change this stack into engine. So just I have to change the parameters, design parameters. I'll go to last cross section. Then I'll change pointed into circle with some dia, and I'll call this is my exhaust part. This one is inlet, and this one is exhaust nozzle part. So okay, roughly let it be this much. Okay, let me change the height and width. So now it's a rough model. So just I'll call this as a engine. Okay, because this one we have to fix here. No? So just uh, I'll fix that. Suppose if you want to fix somewhere here at this location, okay, and that has to be below the wing. Okay, okay. So once one engine if you design, then no need to design one more engine. Just copy this one and paste, and you can come to that extra stack geometry or extra engine which you have created or which you have pasted. That one you just move along negative x location. Okay, so just type here that negative value and enter. But let me select that. 3 point, so just round off this 3.5, and similarly this one also 3.5. Okay, so this one I have to move along y direction. Okay, so yes, along y, let me check its value. Along y how much? 5.7. So I'll round off this into 6. Okay, so now I will select this stack and I just type negative 6 and I will enter. 6, 3.5 and minus 6, 3.5. Okay, so now I will use the top view. Now I will move along x. Along x, suppose you want to place here somewhere. Okay, so I will round up this into 10. Similarly, I'll select this one. Along x, I will type same 10. Okay, now I will select complete components, like select all, and I will shade this one. So yeah, this one is top view, ISO view, side view, and front view. So this is how you can do assembly. Okay, for your respective components. Okay, suppose if you have designed your fuselage as per your requirement. Okay, and similarly if you have designed your main wing or tail wing or stabilizers as per your requirement. Okay, and at the end you can use those all components which you have created, okay, which you have saved in your file. Just call all those components one by one here. Okay, after calling, give name as per your model, which model you are designing. Okay, so after giving proper name like main wing, tail wing, horizontal stabilizer or vertical stabilizer, fuselage. Okay, then each and every component you can assemble. Okay, just by altering the location. Okay, so I will stop here. For this one you can add materials and all that I already told you. So this is all about today's topic. Thank you to everyone for listening the class. Tomorrow I'll continue with next topic. I mean, in the next class, I will continue with the different topic what we have. So thank you.
Okay, thank you, sir.
Okay, thank you.